Hello, my dear students. Good morning to all of you. In today's session, we are going to discuss on very important topic from exam point of view, that is time lags for a breakdown process. Okay. In the first module, we have, as we already started with the various electrical phenomena, we are going to study under the presence of gaseous dielectric medium. Is it right? So, which are those electrical phenomena? One, it is conduction phenomena, and one more is the breakdown phenomena by considering the gaseous dielectric medium. Is it right? So, in today's session, let's start with the time lags for a breakdown. Okay. See here. So, first we need to understand what is time lag itself. The time lagging, some amount of time difference is there for the breakdown process occurrence. So, let us consider this diagram. So, this is the two electrode system, as we are already familiar with this system, right? So, this is the two electrode system. We are going to be applying this is the adjustable high voltage source is there. Is it right? So, when we voltage application, so for a breakdown process occurrence means we need to apply the voltage here. Is it right? So, between these two electrodes we are applying the voltage here. So, the time difference between the application of a voltage at a certain duration t, we are going to apply the voltage between these two electrodes itself. Immediately after the application of a voltage, is there any breakdown process takes place? No, is it right? So, after the application of the voltage between these two electrode process, there is some time it is required for the ionization of the gaseous dielectric medium present here. Is it right? So, that is why, so time lag, how you will define it? The time difference between the application of a voltage, application of the voltage, consider it as a small t, so which is sufficient to cause the breakdown. Getting my point? So, which is sufficient to cause the breakdown immediately after applying the voltage at a time duration of a t. So, it will take some time for the ionization process. So, then only the breakdown of the dielectric medium takes place. So, that time difference, this is going to be called it as what? Time lag. So, how we will define it now? The time difference between the application of a voltage which is sufficient to cause the breakdown, then and the occurrence of, after some time it will take for the ionization process, right? So, it will take some time for the ionization of the gaseous dielectric medium. Is it right? So, then only the breakdown phenomena it is going to be occurs. So, that time difference is going to be called it as what? Time lag. Okay. So, now here as we already studied about the Townsend's criterion for the breakdown. Getting my point? So, when the Townsend's criteria for breakdown it is going to be satisfied. So, when in the sense that at least between these two electrodes, one electron should be present between the gap of these two electrodes. If there is no electron flow, means if there is a moment of the electron, then only the current is going to be flow, right? So, what is the definition of the current? Current, it is nothing but the moment of the electrons itself. Is it right? So, that is why the Townsend's criteria for breakdown phenomena, it is going to be satisfied only when it is between the gap of these two electrodes, at least one electron should be present here. If there is no moment of electrons, means there is no conduction of current. Okay. So, that is why, so the Townsend's criteria should for the breakdown process, that is going to be satisfied only when at least one electron should be present between these two electrodes. Getting? So, let us consider, there are two cases we will consider now. In case, first thing, so in case if the applied voltage which is DC or slowly varying AC, which is of a 50 Hertz voltage, if you had applied between the electrodes, means there is no difficulty in satisfying the Townsend's criteria for breakdown. So, in case of, or else another case I will consider here, if the voltage, whatever the voltage we are applying, if it is of rapidly changing, nothing but the impulse voltage, if you had applied between these two electrodes, impulse voltage in the sense that it will be rapidly changing and which is having the shorter duration, that is of a nearly approximately 10 raised to 6 seconds itself. Is it right? So, in that case, if the voltage is continuously changing in nature or rapidly changing in nature, or it is also going to be called it as an impulse voltage. If you are applied between these two electrodes, means what will happen? Due to the rapidly changing voltage, there is no initiatory electron will not be present in the gap. If there is no electron, means there is no current flow. If there is no current flow, means what will happen? That does not leads to a breakdown of the gaseous dielectric medium, right? So that is why there are two cases what I had considered. So if the applied voltage, which is DC or slowly varying AC, means there is no difficulty in satisfying the condition. Which condition? So condition means that is Townsend's criteria for breakdown. It is going to be satisfied only when at least one electron should be present between this gap of the electrode system. Getting? So that is why the first consideration, applied voltage is of a DC or slowly varying AC, I had taken here. Next, a second case, which voltage we had applied? So that is of a rapidly changing, or else we can call it as a impulse voltage. Impulse voltage means it is a continuously changing voltage. So that is of a duration 10⁶ seconds itself. In that case, what will happen? There may be a chances of there is no, or there is an absence of initiatory electron present between these two electrodes. So if there is no electrons, if the absence of electron is there, means there is no movement of the electrons, means there is no conduction of a current itself. If there is no conduction of current, means that leads to what? There is no breakdown phenomena takes place here. Is it right? I hope this is clear to you. Next, what is there? See here, you can observe here. So this time lag or the time difference between the application of a voltage which is sufficient to cause the breakdown and the occurrence of a breakdown process. Getting my point? So this time lag, it is divided into the two types it is. Which are those? One, it is statistical time lag, that is represented by Ts, and one more is formative time lag. TF it is. Getting my point? The time lag or the time difference between the application of a voltage which is sufficient to cause the breakdown, and after this at a certain time duration T, we are going to apply the voltage. So, and after this application of the voltage, it will take some time for the ionization process, then only breakdown phenomena it is going to be occurs. So that in intermediate time difference, that is going to be called it as what? Time lag itself. So this time lag, it is going to be or of a two types. Which are those? One, it is statistical time lag, that is represented by Ts, and one more is formative time lag. So that is represented by how? TF it is. Okay, now let us define what is statistical time lag and what is formative time lag. Okay, fine. So here, statistical time lag means what? So the time lapse between, the time difference between application of a voltage. So let us consider we are going to applying the voltage for this two electrode system at a time duration of a T. Let us consider at a X amount of a time we are going to applying the voltage to this electrode system. Okay. So the time difference between the application of a voltage which is sufficient to cause the breakdown. So which is sufficient to cause the breakdown. So at what time duration we had applied the voltage between these two electrodes? At a time duration of X amount of a time. Let us consider it as a T itself. Okay. And then, so after application of the voltage, there should be a appearance of ionization or initiating electron should be moment of the electron should be there between these two electrode system. Is it right? So then only, so we can say that the time lapse between the application of a voltage which is sufficient to cause the breakdown and then appearance of initiating electron between this gap. So this time gap, it is going to be called it as what? Statistical time lag. Okay, that is represented by how? Ts itself. I hope this is how we will define the Ts now. The Ts is nothing but statistical time lag. So this is the voltage or this is the time lapse or the time difference between the voltage which is sufficient to cause the breakdown and then appearance of initiating electron between this gap. Where? Between the two electrodes. Getting my point? That shorter time duration, there is some time difference. Getting my point? So that is going to be called it as a statistical time lag itself. Okay, then what about formative time lag? Formative time lag means once the electron appears. Is it right? Once the electron, after the application of the voltage means electrons starts moving through this two electrode system, right? So once the initiatory electron gets appeared, let us consider after appearance of the electrons at a time of a TT, so at a time duration of a TT, which is required for the ionization process to develop fully to cause the breakdown of the gap itself. So at a time duration of TT, the initiatory electron gets appeared. Okay. After the appearance of electron, next what process has to be takes place here? Ionization process. What is that ionization process? Ionization process is nothing but an atom or a molecule. Which atom or the molecule? So here, which atom will be present here? So in between these two electrode, which dielectric medium is present? That is gaseous dielectric medium. Is it right? So that gaseous atom or the molecule which acquires the positive or negative charge. How it will acquire positive or negative charge? By gaining or losing the electrons itself. So that process it is going to be called it as what? Ionization process. Is it right? So that is why how we will define the formative time lag means after appearance of this initiating electron at a certain time duration, let us consider TT. So initiatory electron has been appeared now. So after this once the electron appeared means next it leads to what? Ionization process. Ionization of what? Gaseous medium present between these two electrodes. Okay. So that is why after appearance of the electrons at a time duration of TT, which is required for the ionization process. Once the ionization process of this the gaseous atom or the molecules gets ionized means that leads to a breakdown of this gaseous medium here. Is it right? So that time duration it is going to be called it as what? A formative time lag. So that is represented by TF here. So I think, so now how will define the total time now? The total time lag. So that will be represented by T. This will be the sum of what? Statistical time lag as well as the formative time lag itself. So getting my point? And here the statistical time it will be depends upon the some factors. So what are those factors? Okay, so see here we can observe this diagram here. So this is the statistical time lag. After this formative time lag is there. The summation of these two times it will give the total time lag here. So this is the applied voltage here, and this is nothing but what? After initiation of the electrons or after ionization of the gap or the between the gap between the electrodes completely means the voltage it is going to be gets collapsed. Is it right? So nothing but what? Breakdown phenomena of a dielectric or the gaseous medium takes place. Is it right? So this is all about time lag itself. Is it right? So now next what I am telling here, this TS, nothing but statistical time lag, it will depends upon the some factors I told here. So which are those factors? The first one is amount of pre-ionization which is present in the gap. Getting my point? The second factor is the size of the gap, nothing but the difference between the two electrodes, how much distance is there. So that is also very important. Next one is the quantity of radiation that produces the primary electrons. Quantity of radiation means how here? So this cathode it is going to be irradiated with the help of the, or irradiated in the sense that exposed to the ultraviolet radiation which is of a suitable frequency. If it is incident on this cathode electrode means what will happen? So that is the quantity, the amount of radiation which is passing on the cathode electrode, it will produce some primary electrons itself. Getting my point? Then what will happen? These primary electrons collides with the neutral gaseous molecules which are present between these two electrodes, right? So that process it is going to be called it as what? Ionization by collision process. Is it right? So what I am telling here, so the statistical time lag, it will depends upon the three factors. Which are those? The first one is the amount of pre-ionization present between the gap of these two electrodes. Second one is the size of the gap, nothing but the distance between the electrodes, which will decides the breakdown phenomena of the two electrode system. Next, third one, which one is? So the third one is the amount or the quantity of radiation which is incidenting on the cathode itself. So this cathode electrode, it is exposed to the ultraviolet radiation, which is of a suitable frequency that generates what? Primary electrons. So these primary electrons collides with the, so what molecules will be present here in this gap? So that is gaseous atoms or the molecules. So these electrons collide with the neutral gaseous molecules, that results into a production of the primary electrons. Again these electrons are going to be starts moving and again they collides with the neutral gaseous molecules, and that will leads to a ionization process. So this is like what? Chain process or nothing but the chain reaction process. Is it right? So next thing here. So this is how TS it is going to be depends upon the three factors what we have seen. After this, one more is the formative time lag. So this formative time lag, it will be depends upon the very important factor, that is mechanism of avalanche growth in the gap. So what is that avalanche growth? What is the meaning of this avalanche growth? So here avalanche growth, the formative time lag depends upon the mechanism of a avalanche growth in this gap I told here. So what is the meaning of this avalanche growth? So avalanche growth, it is nothing but it is a process in which what will happen? It is a process in which free electrons, when we apply the voltage, electrons are going to be starts moving. Is it right? Starts flowing here. So here the process in which the number of free electrons in a transmission medium, which medium it is? Gaseous medium is present here. So the number of free electrons in a transmission medium which are subjected to the strong acceleration. How they are going to be subjected to strong acceleration? By application of the electrical field here. Is it right? So then what will happen? Subsequently, these electrons are going to be collide with the other gaseous medium here. The neutral gaseous atoms collides with the free strongly accelerated electrons itself. So that leads to the what? Ionization process. Again during the ionization, after the ionization process, some additional electrons are going to be gets releases. So these additional electrons again accelerates and collide with this neutral gaseous molecules in the same way. So it is nothing but what? Releasing more number of electrons itself. It is like a chain reaction, or else this is going to be called it as a avalanche growth itself between this gap. So that will be depends upon the formative time lag, means it will be depends upon the very important process, that is nothing but the avalanche growth in the gap here. Is it right? So now we can say here, so here we can observe it here, the secondary electrons which are produced. When the secondary electrons are going to be produced, we have already discussed about the ionization process due to the secondary electrons itself. We have already discussed about how the electrons are going to be emitted by the secondary ionization processes. The first one is electrons are going to be gets emitted due to the impact of positive ions, or due to the impact of the photoionization process, or nothing but the effect of photons. Photon, it is nothing but the packet of energy itself. So on that cathode electrode, it is going to be exposed to the ultraviolet radiation, which is of a suitable frequency. Is it right? So that is also one more thing here. So where the secondary electrons which are going to be produced due to the effect of what? Cathode, by either it is by positive ions or it is by the what it is, or it is by the photons, or it is by the metastable atoms as well as the neutral atoms itself. So this formative time lag will be depends upon the two factors. The first one is mechanism of avalanche growth in the gap, and the second one is secondary electrons, how they are going to be produced due to the three reasons: due to the impact of a positive ions, or due to the impact of a photons, or due to the impact of what? Third last one is metastable or the neutral atoms. I hope this is clear to all of you. So just now what we have discussed, that is nothing but time lags for a breakdown phenomena. So this is very important from exam point of view. Just you concentrate on this. Okay. So here just we have a glance about this one. Time lags for breakdown means what is the definition of time lag? It is nothing but the time difference between the application of a voltage. So at a certain time duration, we are applying a voltage between these two electrodes. Let us consider at a certain time, X amount of a time is there, that you consider it as a T. Okay. So now, we have applied the voltage at a time duration of a T itself. And after this application of the voltage, it will take a certain time to get ionize this neutral gaseous molecules. Then only the breakdown phenomena it is going to be occurs. So that time difference is going to be called it as what? Time lag. Okay. Next what I told here, the time lag which is of two types are there. Which are those? One it is statistical time lag and one more is the formative time lag. Getting my point? So definition we already discussed now, and after this this TS statistical time lag will be depends upon the very important factors. Which are those? Nothing but the first one is amount of free ionization which is present in the gap, and next one is the size of the gap, and the last one is the quantity of radiation that produces the primary electrons. Getting my point? Formative time lag means it will be depends upon the two factors. Which are those? One it is mechanism of avalanche growth in the gap, and the second one is the secondary electrons, how they are going to be produced due to the effect of what? Due to the impact of positive ions, or due to the effect of the photons, or due to the impact of what? Metastable or the neutral atoms. So this is how the time lag for the breakdown process what we have explained till now. Okay. I hope this is clear to all of you. Okay. In next class, we'll start with the very important theory, that is nothing but streamer theory for a breakdown in gaseous dielectric medium. Okay. So till now whatever we have discussed means that is all related to what? Townsend's theory for breakdown phenomena. So next one more very important theory, the mechanism of breakdown phenomena, that can be well explained with the help of by the two scientists. One is Townsend's, one more is Streamer is there. So till now we have completed with the Townsend's theory. Next we'll move on to Streamer theory. I think just we can say here the Townsend's theory which is having some drawbacks itself. So in order to overcome those drawbacks, the Streamer theory has been developed. Okay. So that Streamer theory, it is very important process which is occurs in the breakdown of the gaseous dielectric medium. Okay. So that will explain in the next class. Okay. Fine.